Assalamualaikum, my name is Sharifah Nur Shamimi. I will start with introduction to ECE3. In civil engineering, choosing the right materials, method and ensuring compliance with standard is critical for project success. This is especially important for mega projects like the East Coast Expressway 3 or ECE3. ECE3 spans to 30 kilometers of challenging terrains include valley, ponds, and hilly areas. The first phase will include 2 lanes in 2 carriageways and require intensive cut and fill work to stabilize the road base. To enhance project delivery, advanced technologies like building information modeling or BIM and drone will be used. BIM allow real-time collaboration to reduce error and improve efficiency, while drone provide aerial data for better site analysis and monitoring. Considering the diverse terrain, we will also focus on detailed geological and environmental assessment. This ensures soil stability, safety, and sustainability while adhering to all required standards. As a project management consultant, our role is to provide strategic guidance or material selection, construction method, and compliance to ensure this project is functional, sustainable, and cost efficiently.
My name is Alicia Mira binti Zainuddin and I will continue this presentation on reason of the selection of structural type or method of construction. The reasons for the selection of structural type or method of construction are being influenced by several factors which align with the project's objectives and the unique characteristics of the terrain. Besides, the terrain types involved in this project are valley, pond, and hilly areas. For adaptation to terrain can be defined as the process of altering and maximizing the land's physical features to provide a secure and reliable base for roads. For the first terrain type involved in this project, which are valleys, it is necessary to construct bridges and viaducts. Bridges and viaducts are necessary for this project in order to cross low-lying areas with the least amount of negative environmental impact. By maintaining natural water flow and lowering the risk of erosion, these structures provide connectivity without causing significant ground disturbance. Next, ponds. For pond regions, embankments or culverts can be used to either bypass or allow water passage while ensuring road stability. Geotextiles and other ground enhancement techniques can help assure the foundation stability. Ponds frequently have water-saturated, weak and compressible soils such as silt or clay. These soils may not have sufficient carrying capacity for road foundation. The third terrain type involved in this project is hilly areas. Cut and fill methods are crucial for creating a level and steady road foundation in hilly areas. The approach entails excavating soil and rock from one region and using that material to build up another area, resulting in a steady and level roadbed. To stop erosion or landslides, retaining walls or slope stabilization techniques such as rock bolts or rock soil nailing may be used. Moving on to construction efficiency and cost, choosing a construction method that is compatible with the selected structural type guarantees that the project runs smoothly. Early contractor involvement in the design phase might offer new solutions that save costly variation and rework, hence increasing overall efficiency. Furthermore, by aligning the road design to follow the natural contours of the terrain, excessive excavation or filling can be avoided, which leads to a more efficient and sustainable construction process. In addition, the material selection of the East Coast Expressway 3 project is essential to ensure stability for terrain conditions. For valley areas, the use of bridge or viaducts to withstand dynamic loads and environmental conditions, strong and long-lasting materials like steel and reinforced concrete are necessary. Additionally, the pressure on soft valley soils can be lessened by using lightweight fill materials like geofoam or expanded polystyrene, which will ensure stability and minimize settlement problems. Moreover, for pond areas, durability in dam situation is ensured by materials with high water resistance, such as precast concrete culvert and impermeable clay for embankments. Lastly, pavement selection. For this proposed East Coast Expressway, the type of pavement that will be used is rigid pavement. Rigid pavement is a form of road surface made up of concrete slabs that is designed to distribute traffic loads across a large area. Rigid pavement effectively distribute vehicle weight across a broader area, lowering stress on the underlying soil and subgrade. This is critical for expressway that will face high traffic volumes. Rigid pavement is ideal for this kind of situation because it can take enormous loads without substantial deformation or rutting, resulting in a strong and durable surface for high speed and high volume traffic. Other than that, skid resistance. Skid resistance refers to the pavement surface capacity to provide enough friction to avoid vehicle skidding, especially in wet weather or in regions prone to water collection, such as around pond crossing along the alignment. The rigid pavement concrete surface can be textured during construction to maintain proper friction levels, which improve vehicle grip even in wet circumstances. This is especially important in the valley and hilly areas of the highway, where curves and slopes heighten the risk of skidding.
Today, I will present on the proposed design consideration for the East Coast Expressway 3 or ECE3. The first one is traffic volume and flow. Traffic volumes and flow are the backbone of effective expressway design. First, let's look at two important terms, which is traffic volume, means how many vehicles pass a certain point on the road in a specific amount of time. Traffic flow is how this vehicle move, either smoothly or slowly, when there's congestion. It's also critical to track traffic congestion accurately. Studies show that factors like service areas can affect how smoothly traffic flows. Traffic change at different times of the day. By studying this pattern, we can design the expressway to handle traffic better during busy times. Traffic is also influenced by many things including weather. For example, bad weather like rain can slow down the traffic and make travel time less reliable. Next, road must handle different vehicles like trucks and cars, which move differently. If the ECE3 is designed with this in mind, the traffic will make efficiently no matter the situation. Now, let's move on to route classification, a critical part of designing the East Coast Expressway 3. Roads are generally divided into three main types, which is local roads. These connect to home, shops, and business. Next, arterial roads, which carry more traffic and connect major areas. And the last one is expressway, which is high-speed road with limited access, designed to handle large volume of traffic. Next, let's talk about geometric design. For the East Coast Expressway 3, ECE3, which is planned to have 2 lanes and 2 carriageways, geometric design is critical for ensuring the road is sustainable, efficient, and safe. The width of the lane is one of the most important parts of geometric design because it affects both the road capacity and safety. Research shows that on expressway with lower speed limits, slightly narrower lanes can be used if safety is carefully managed. Designing the lanes must also consider heavier vehicles which behave differently than passenger cars. The expressway should allow both types of vehicles to move smoothly. The alignment of the road in curve and slope plays a big role in driver safety and behavior. To ensure safety, the curve on ECE3 need to be gentle and consistent. Consistent design helps drivers feel confident and reduce the chance of accident. Another key aspect is drainage and to prevent water from collecting on the road, which can damage the surface and make driving dangerous. A well-designed cross-slope also ensures water flow of the roads, reducing risk in wet conditions. Including effective drainage features in ECE3 will improve both safety and the durability of the road. Now, let's discuss about material selection, which is crucial for building for construct a durable, sustainable and cost-effective East Coast Expressway 3. The material used in highway construction play a big role in how well the expressway perform over the time. For example, pavement material affect the road's ability to handle heavy loads, resist damage and minimize maintenance needs. Using high-quality asphalt mixtures can make the road more durable, reducing repairs and ensuring a longer lifespan. Choosing the right materials is essential to prevent issues like cracking and deterioration once the road is in use. And another key consideration is the environmental impact of the material. By carefully selecting materials for the ECE3, we can achieve durability for a longer-lasting expressway that requires fewer repairs. And next, cost-effectiveness for lower maintenance costs over time. And the last one is sustainability to reduce environmental harm and support for eco-friendly practices.
For the annotated sketches, we have prepared 3 sketches. The first sketch is on the cut and fill method. Next, this is the rigid pavement sketch. And lastly, this is the proposed East Coast Expressway through hilly areas.
We continue with construction process with appropriate machineries used in construction. Let's go through the construction process of the East Coast Expressway 3 or ECE3. This proposed 30-kilometer highway includes a 2-way and 4-lane road and also require intensive cutting and filling to address its challenging terrain of valleys, ponds, and hills. For the first one is site preparation. The process begins with site preparation, which include land acquisition, clearing vegetation, and ensuring compliance with the Land Acquisition Act. Detailed soil and tomography surveys provide critical data for design and construction planning. For the second one is earthwork. We will move to earthwork, which involve cutting elevated regions and filling lower ones. The machineries used include bulldozer for clearing and shaping the lane, excavator for digging trench and moving earth, and also dump truck for transporting excavation materials. And this phase reshape the terrain and prepare it for road construction. And number 3 is road foundation construction. After earthwork, the focus shifts to the road foundation subgrade preparation, compact the soil for stability using roller to achieve the required density and compactor to prevent settlement. Then a layer pavement system is built including a granular base and alphate binder for strength and a high quality alphate surface for smooth and skid resistance driving. Next is drainage system. Proper drainage system like culvert and discharge are essential to channel water flow and prevent erosion, rust, and damage to the road. And next is environmental consideration. Environment impact assessment are conducted to minimize harm to the local ecosystem. This assessment help define risk mitigation strategy to protect vulnerable areas. And the last is traffic management. A traffic management plan is critical to ensure minimal disruption during construction. So this include temporary traffic light, detours, and lane closure if necessary. The successful completion of ECE3 will enhance connectivity on Malaysia East Coast and addressing geographical challenges with advanced machinery like bulldozer, escalator, roller, and compactor alongside strategy planning.
Now let's talk about the contractor's requirement for temporary works during the East Coast Expressway 3 construction. Temporary works are crucial to ensure smooth project execution, safety, and environmental protection. The first one is temporary road access. Temporary access roads play a key role in allowing workers, equipment, and construction vehicles to move safely and efficiently to and from the construction site, supporting the heavy loads of machinery like excavator and dump trucks. This road must be wide enough and stable to handle the stresses caused by construction activities. To follow sustainable practices, the surface of this access road should be stabilized with compacted gravel to reduce rutting and improve durability. A regular maintenance schedule is needed to keep the roads in good condition, prevent accidents, and ensure smooth operation throughout the construction phase. Next, let's explore the importance of site facilities in ensuring the smooth and successful completion of the ECE3 construction project. Site facilities provide essential services that support workers by ensuring their comfort and welfare. Maintain operational efficiency by minimizing disruption during the construction, and to promote safety and comply with regulation to ensure a safe and productive work environment. Contractors must provide basic amenities such as restroom, locker rooms, break areas, and drinkable water for worker comfort. Next, temporary shelters and site office equipped with basic necessities to meet occupational safety and health regulation. And the last one is temporary electricity and water supply system also must be installed to support construction activities. And the last one is secure storage is critical to maintaining safety and preventing theft. And the last one, machinery. And now let's move on to the next point, which is the importance of a temporary drainage system for the East Coast Expressway 3 project. Efficient drainage is essential for controlling stormwater runoff and preventing flooding during construction. A well-designed temporary drainage system helps to control stormwater runoff to prevent flooding, protect the construction site and surrounding environment, and to ensure the safety and efficiency of construction activities. Key elements of a temporary drainage system include ditches and channels to direct water flow, culvert and sedimentation basins to filter pollutants and manage runoff. And so these elements work together to safely manage water flow and protect the environment from pollutants. It is also important to divert water flow away from active construction area to minimize disruptions. Maintain site safety by preventing water from accumulating in the work zone is also essential. The last point is traffic management measures. These measures ensure that both public traffic and construction vehicles can pass safely around the project site. Traffic management is crucial for safety, for keeping the road users and workers safe during the construction. Next, minimizing disruption and maintaining smooth traffic flow. And the next one is accident prevention by reducing the risk of accident in construction zone. To keep public traffic away from construction zone, clear signage such as warning signs, diversion notice, and directional arrow should be placed strategically to guide road users. To ensure safety and traffic flow, physical barriers like concrete blocks or water-filled barricades are used to separate work zone from traffic lanes. Speed limit around work site must be enforced and prominently displayed to prevent accidents caused by fast-moving vehicles. Flag workers are also need to station at key locations like junction or busy areas. These workers also must wear reflective vests and be trained in traffic management. Communication device also essential to keep the flow of information clear and effective.
Assalamualaikum warahmatullahi wabarakatuh. My name is Damia Batrisha Akasha. Today I will be presenting the work program and method statement for our project. These sections outline the planned schedule and detailed construction methodology which are critical for ensuring the project's success. The work program serves as a comprehensive schedule for the project, breaking down tasks into manageable phases. It ensures that every activity is completed on time while maintaining quality and efficiency. For this project, the key phases include site preparation, earthworks, drainage system installation, road foundation construction, and final finishing works. Let's look at the key phases in more detail. The first one is site preparation. This involves clearing the site, obtaining necessary permits, and conducting soil and topography surveys. The second one is earthworks. Activities like cut and fill operations to reshape the terrain are conducted, utilizing equipments like bulldozers and excavators. The third one is drainage system installation. Proper drainage systems such as culverts and ditches are installed to manage water flow. The fourth one is road foundation construction. Layers of the roadbed are built, including granular base layers and asphalt paving. And last one is final finishing works, which includes pavement marking, lighting, and landscaping. Moving on to the method statement, this section outlines the step-by-step approach to execute the construction activities safely and efficiently. It specifies the techniques, equipment, materials, and safety measures to be used for each phase. The key steps in the method statement for this project includes preparation, which mobilizes resources, establish site access, and set up temporary facilities like worker shelters and storage areas. The second one is excavation and earthworks, which uses heavy machinery to perform cut and fill operations while ensuring compliance with safety protocols. The third one is foundation works. This involves constructing the subgrade using compactors and rollers, followed by placing reinforced concrete for stability. The fourth one is drainage installation, which installs the drainage channels and culverts, ensuring proper alignment and slope for effective water management. The last one is superstructure construction. This involves erecting bridges or viaducts in valley areas and stabilized slopes with techniques like shotcrete or soil nailing. In conclusion, the work program and method statement provide a structured roadmap for completing the project efficiently and safely. By following these detailed plans, we can ensure timely delivery, maintain quality, and meet safety and environmental standards. Thank you.
In conclusion, the East Coast Expressway 3 or ECE3 is a massive infrastructure project that faces significant challenges due to its diverse terrain of valleys, ponds, and hills. The success of this project depends on efficient construction cost control and compliance with safety and environmental standards. Using advanced technology like building information modeling and drone ensure better collaboration, reduce error, and shorten project timeline. This tool also contribute to sustainability by minimizing material waste and promoting environmental compliance. For recommendation, to achieve the project goals of ECE3, we recommend the following. First one is detailed terrain analysis conduct throughout geotechnical studies to guide material selection and design for stability and durability. And second one is adoption of advanced technologies like use BIM and drone to enhance project efficiency and accuracy while reducing timeline. And third one is sustainable material selection. Choose durable materials suited to each terrain type, such as water resistant material for pond area and reinforced concrete for bridge. And the fourth is traffic flow consideration. Design with traffic capacity in mind, ensuring sufficient lane for both passenger car and heavy vehicle. And And by implementing this recommendation, ECE3 can achieve its goal of providing a safe, effective and sustainable expressway that meet user needs while staying within budget.